This video covers the first part of Review 3 over exponents and radicals. So for problem 1, we're asked to simplify each expression and show our work. So the first thing I notice is I have these parentheses here, and I'm going to need to distribute that -4 to the 3 and to the -8. Now remember, when we distribute, we multiply, and in this problem we are multiplying. And when I look at the rest of my equation, the bottom has not changed. So I'll have 12 and x to the -11 with no change. So first, I'm going to look at my numbers. So I have 3 to the -4 over 12. And in my calculator, I can put that in exactly like I see it. I'm going to click alpha y equals enter. 3 raised to the -4 divided by 12. And it tells me the fraction 1 over 972. And again, I just put this into my calculator exactly like I see it. Then, for my letter, I have x to the -8 times -4 over x to the -11. So remember, anytime we have division, I'm actually going to subtract. So I'm going to erase that bottom part and add this back in to the top. So over here, I have x to the -8 times -4 minus -11. And I'm just going to put that into my calculator exactly like I see it. -8 times -4 minus -11. And I get 43. That's not 43, sorry. Where's my x to the 43. And this stays on the top because I don't have any negative exponents. So my full answer together will be x to the 43 on top and 972 on the bottom. So that's kind of an ugly one. Problem 2 gets a lot nicer. So for problem 2, I have my number 2, and that's the only thing there, so it's going to stay. I have a to the 0. Remember, anything to the 0 goes away. B to the -4 is going to be pushed down to the bottom. So you can write it like this, or just draw the arrow underneath to remind yourself to push it to the bottom. And then C just stays as C. So my final answer, 2 stayed and C stayed. And B to the 4 pushed down to the bottom to become positive. Problem 3, I have -4 times a to the 4th times -5a to the 3rd. So I'm going to do it number by number. So I have -4 times -5. -4 times -5 is a positive 20. And then with my letters, I have a to the 4 times a cubed. Remember, anytime we see a multiplication but our letters are split up, we actually add. So 4 plus 3 is 7, and that's positive, so I will keep it on the top. So my answer will be 20a to the 7 with no other changes. So problem 4, I'm going to do the same thing. My letters, I have 4 and 3, and I'm sorry, I meant numbers. Numbers 4, 3, and -2. For my A's, I have a cubed, and a squared. And then for my B's, I'm going to box them. 2 and B to the 4. So numbers, 4 times 3 times -2 is a -24. A's, I have addition, so a to the 1 plus 3 plus 2 is 6. And with the B's, I'm also adding, so 2 plus 4 is 6. And I put it all back together. Both of these are staying on the top because they're both positive. Problem 5, I'm going to put my numbers in one piece. -15 divided by 18. My A's, I have a to the 4 over a squared. And B's, I have B3 over B6. So my number, I'm going to put into the calculator exactly like I see it. Negative 15 over 18, which gives me negative 5/6. For my a's, I'm going to subtract because they're being divided. So a to the 4 minus 2 is 2, and it's positive, so I'll leave it on the top. And then for my b's, I'm subtracting also. So 3 minus 6 is negative 3. So that will be pushed down to the bottom. So for my final answer, I have my negative 5 over 6. A squared is staying on top, and b to the 3 is pushing down to the bottom. And I can leave my answer as such. Problem 6, I'm going to do the same thing. Number, A's, B's, and my C. So with my numbers, 20 divided by 4 is 5, and I leave it there. With my letter, a to the negative 5 minus 6. Negative 5 minus 6 is negative 11. And because it's negative, that will push down to the bottom. With my b's, oh, that's supposed to be a 6, I'm sorry. I have 6 minus 2, so that would give me 4. And c to the 0 will cancel because anything to the 0 power is nothing, or cancels. So for my answer, I have 5 and b to the 4 on top, and a to the 11 pushes to the bottom. So for problem 7, I need to distribute the 2, so 6 squared, a to the 1/4 squared. And then this is just another multiplying, a to the 1/2 times 4. So with my numbers, I have 6 squared. And with my a's, I have 1/4 times 2 and 1/2 times 4. And they're split up, so I will add them after I multiply them. So I multiply them and then add them together. So 6 squared is 36. For the a's, I can put that into my calculator exactly like I see it. 1/4 times 2 plus 1/2 times 4. And I get 5 halves. And it's positive, so it will stay on the top. And for problem 8, everything gets a 5. So 4 gets a 5. B to the 5 gets a 5. And e to the 0 gets a 5. When I break this up, 4 to the 5th is 1024. B to the 5 times 5 is 25. And e to the 0 times 5 is e to the 0, which just cancels. So my full answer is 1024, b to the 25. For problem 9, I'm going to distribute that 3. So 3 gets a 3 and a squared gets a 3. And then all of this gets a 0, which means all of that cancels. So 3 cubed is 27. And a to the 2 times 3 is a to the 6, and it stays on the top because it's positive. Problem 10, I'm going to break it up with my numbers first, 3 and 7. My a's, I have 1/3 and 4/3 over here. And then b's, I have 1/4 and 3/2. So 3 times 7 is 21. A to the 1/3 plus 4/3 is 5/3, and it's going to stay on the top. And then b to the 1/4 plus 3/2 is b to the 7/4, and that stays on top as well. So 21, a to the 5/3, b b to the 7/4. Problem 11, this one kind of has a lot going on, so I'm going to distribute first and then put everything together as much as I can. So on the top, 6 gets a -2, k to the 10 gets a -2, m gets a -2, the bottom stays the same. And over here, everything on the bottom gets a -1, the top will stay the same. So 3 gets a -1, and m to the -4 gets a -1. So I'm going to put all of my numbers together exactly like I see them. So I have a number, a number, a number, a number. So 6 to the -2/4 and 2 over 3 to the -1. And all I'm going to do is put that exactly like I see it into my calculator, ugliness and all. So 6 raised to the -2/4 times 2 over 3 raised to the -1. And it tells me the answer is 1 over 24. So let the calculator work out that ugliness for you. For the next part, I'm going to look at my k's. So I have k's on the top and on the top. So k to the 10 times -2 plus 8 because it's on that other side. So we got -20 plus 8, which is -14. So that will push to the bottom. And then m's, I have a -2 on top, a 3 on the bottom, and a -4 to the -1. Remember, we multiply these, so that's a +4 on the bottom. So I have a -2 on the top, a 3 on the bottom, and a 4 on the bottom. So I'm going to subtract all of those. So -2 minus 3 minus 4 is a -9. And because that's negative, it's going to push to the bottom. So my full answer I'm going to write up here at the top, 1 over 24. K to the 14 moves to the bottom and becomes positive. M to the 9 moves to the bottom and becomes positive. Problem 12 is a little nicer. I look at my A's. So I have 2 on top, and I'm taking away 4/3. So 2 minus 4/3 is 2/3. And it's positive, so it stays on the top. And my B's, I have 4 on the top, and I'm taking away 3/2. And so I get B to the 5/2, and it's positive, so it stays on the top. So I have A to the 2/3 and B to the 5/2. Oh, cute. 5/2. Okay. Problem 13, ask you to convert. So remember, when we convert, that number that's on the top pops down to the bottom, and then the number on the very bottom pops out to the outside. So bottom pops to the outside, top pushes to the bottom. So I take this 2 and push it out. Take the 3 and push it down. And that is my simplified form. So for this one, push the 2 out, push the 5 down, leave the 54 where it is. So problem 9, we're going back the other way. I'm sorry, this is problem 15. So remember, if there's not a number listed, it's probably an invisible 2. So this 5 got pushed down, so we're going to push it back up. And the 2 on the outside came from the bottom, so we're going to put it back on the bottom. So outside pushes to the bottom, inside pushes up. So 16, we got an invisible 2 here. 12 GM stays where it is. 4 pushes up. 2 pushes under. And some forms, depending on the test, might ask you to simplify. 4 divided by 2 is 2. So you could simplify like that as well. All right, so problem 17, we're going to simplify these square roots. So when we simplify, I notice this is 72 and 10, and you are more than welcome to simplify however you want. I'm the type of person that likes to get those prime numbers, so I simplify all the way to the prime numbers. So 72 breaks down into 8 and 9. 9 is 3 and 3. 8 is 2 and 4. 4 is 2 and 2. And 10 is 2 and 5. So my primes are 2, 2, 2, 3, 3, 2, 5. And I'm going to double check this on the calculator. 2 times 2 times 2 times 3 times 3 times 2 times 5 is 720, so I did that correctly. And in order to get out of this, because right now we're still under the square root, we've just made it look different, I need a pair, so I'm going to bring out a 2. I have another set of 2's here that are going to come out, and a set of 3's. And then inside the square root is still a 5 that has no friends to come out and play. And then on the outside, 2 times 2 times 3 is 12. And then the square root of 5 stays inside. Okay, so we got another one here. 375 is divisible by 5. So 5 and 75. 75 is 5 and 15. 15 is 3 and 5. So I have 3, 5, 5, and 5. When I double check, 3 times 5 times 5 times 5 is 375. So I've pulled out the right numbers. So in order to get outside the square root, you have to have a friend. There was already a 3 there. This 3 and this 5 will stay inside. So outside, 3 times 5 is 15. Inside, 3 times 5 is 15. And remember, you can do a quick check in your calculator. You can do 3 square root of 375, which is 58.09 as a decimal, and then 15 square root of 15, which is the exact same decimal. So as long as you get the same decimal, then you've done it correctly, and you can move on. So problem 19, the square root of 196, if I plug this into my calculator, I get 14. There is no square root in my calculator, so I leave 0 square roots in my answer, and I move on to the next problem. So problem 20, 405 is divisible by 5, so 405 divided by 5 is 81. 81 is 9 and 9. So 6 was already there. I have a 5, a 9, and a 9. I'm going to double check that, and 5 times 9 times 9 is 405. Now I said I was a prime person, but I'm also a pair person. Why am I going to do more work when I can already see a pair here? So you could keep going all the way down to 3's if you want. So I already had a 6. I'm bringing out a 9. This 5 is staying inside the square root. 6 times 9 is 54. Square root of 5. And to double check myself, in the calculator, 6 square root of 405 is 120.7. 54 square root of 5 is this same square root, so I know I've done it accurately. Problem 21 tells me the area of a rectangle is 12 A7B4, the width is 4A squared B squared. What is the length? They give me the formula right here, so I'm going to plug in what I know. Area equals length times width. My area, it tells me, is 12A7B4. They ask me for the length, and the width is 4A squared B squared. So I'm trying to solve for L. These are being multiplied. So I'm going to divide both sides by 4A squared B squared. On the left side, on the right side, that will cancel. On the left side, I'm going to break it up number by number, letter by letter. So 12 divided by 4 is 3. A to the 7 over a squared is 7 minus 2, so 5. And b to the 4 over b squared is 4 minus 2, which is 2. So I'm going to write it on this side. 3, a5, b2 would be my answer. 22 says the expression of x to the negative 10x to the 4th is equivalent to x to the n. What is the value of n? So I have x to the negative 10, x to the 4th is equivalent to or equals x to the n. So remember, if my exponents are separated like this, we add them, and that would equal my n value. So basically, I'm just looking at those exponents, and negative 10 plus 4 is negative 6. So n would equal negative 6 because that would be the simplified version.